of the 20th century. So to me, this is a very effective way to show that the planet is warming. So temperature is rising because of CO2. The CO2 is from our energy production, and the greenhouse effect is established. Our role is established. Temperature is rising. An important thing in climate science is the if-then connection. If this is true, then this must also be true. And it's an important way to validate and to deal with criticisms, many of which are quite legitimate. So, for example, if the Indian Ocean is cooling and the planet is warming, how can that possibly be so? And so scientists need to go and look at these sort of if-thens. So things that ought to matter, for example, would be sea levels and heat content of the oceans, glaciers, Arctic ice masses, and extreme weathers, because all of these should be affected if the average temperature is rising. So perhaps you don't believe these temperature measurements. Let me show you some other proxies for temperature. So, for example, scientists have been looking at these for a long time, at least 30 or 40 years, to try and cite some things out. So one of them is the probability to have extreme weather. So you can think about the average temperature in Amritsar as a bell curve, a Gaussian distribution, and if the average temperature changes a little, then the extremes change a lot. And so this was brought to light in this absolutely beautiful paper. It's a little old now, 2012. Jim Hansen was one of the leading scientists at NASA. He's now retired, but he published this really fascinating paper, which I believe, and when I speak about climate to the public, is one of the most powerful visual demonstrations of the role of temperature. So let's take, for example, the average temperature, for example, in San Francisco from this period of time. And I record those numbers as a function, and then I make a plot of them and I obtain a bell curve. And we all know what those look like. There are error bars. So for example, the average in San Francisco turns out to be 12C. And by average, I mean day-night over the whole year. Okay? And then these represent the distributions. And you recognize that 2 and 3 sigma events are very rare. Okay? That's what it means to be in a bell curve. So what these guys did is they said, how much of the Earth has experienced a temperature larger than 2 to 3 sigma in recent times? So we're going to make a map of the world, and the colors on the map of the world are going to represent the 2 and 3 sigma events as a function of time. And what's the comparison data? They'll take the data from those parts of the world, from this window of time, and make an average of them. Okay, you with me so far? So, as I mentioned before, a very small change in the average has a very large effect on the tails. So here, for example, is the difference between these two curves, which shows a very large peak here. So here's their plot. These are extreme weather events. So red is 2 sigma and brown is 3 sigma hot. Purple and dark blue are 3 and 2 sigma cold. So here's the world in 1955. And remember, the average for this is 55 to 81. Here's the world in 1965. Here's the world in 1975. Here's the world in 2011. And as we said before, 2015 and now 2016 are even warmer still. So the probability to have an extreme warm event is much, much higher because the average temperature has moved up slightly. A very, I think, powerful graphic. Now, what are the consequences of warmer weather? There are many, and I'll come back to them in a few minutes, but I want to close today. Yeah, there's a little time here. What time do you, how much time do I have?
Probably 5 minutes.
Okay, just enough time. So, 2 men are walking on the streets of Italy in the summertime, and they're talking to each other, and they say, one of them says to the other, let's go to a bar and have a cup of beer, because if we stay out on the streets, we're going to get into a fight with the other gang. Well, they do get into a fight with the other gang, and as it turns out, Romeo tries to intervene between the 2 gangs. 2 deaths happen in that brief period of time, and so begins one of the most famous tragedies, Shakespearean tragedies, in all of English literature. And it really starts with this claim that one man makes to the other, it's a hot day, and if we go outside and run into this gang, we're going to start a brawl, start a fight. Is that true? If it's warmer than the average, are we likely to get into a fight? And so in the era of big data, my colleague Solomon Shing at UC Berkeley and a couple of his now former students asked the following question: what is the relationship between temperature and violence? Now we have to be careful here. We're not talking about absolute temperature. It's not like the warm places of India are more violent than the cool places. The question is, what is the temperature relative to the average? And so Solomon and his colleagues have constructed, first of all, this nice map in which we look at the southern hemisphere, sub-Saharan Africa, Eastern Africa, sub-Saharan Africa, and the whole southern hemisphere. Here's the percent increase of conflict as a function of the temperature for East Africa. Now, I want you to call your attention that the error bars are pretty large. And they have to be large because these kind of events in temperature are rare. It isn't very often that it's minus 2 degrees C colder in Eastern Africa. But nevertheless, the trend seems to be quite clear. Now look at the difference here. If you go up by 2 degrees C, you're talking about an 80% increase in violence. How about civil war in sub-Saharan Africa? That's the blue region right here. Notice it's a different temperature scale, but you still see a significant increase in the probability of violence with increasing temperature. How about in the entire global tropics? Same relationship, increased violence with increased temperature. Now there is a tendency, and I apologize, that some Americans would look at data like this and say, well, that's true for those people, but it's of course not true for us. But big data is phenomenally frustrating to many of us. So here's violent personal crime in the United States. Here's the jurisdiction, the temperature, degrees C, and here's the change in probability. Here's rape in the United States, same relationship, and here's intergroup violent retaliation in the United States, same relationship. So two communities are taking climate change very seriously in the U.S. One is the police, and the other is the armed forces, because they see these kind of increases as being clearly related.
But it is opposite in India.
It is what?
It is opposite situation in India.
Political.
Kashmir is very cold.
That's a good joke to end today on. We're going to come back tomorrow at 2 o'clock, and I'll revisit some of the other consequences of CO2 emissions, and we'll go on from there. Okay? So we're all set? Thank you. I'll see you all then.
Pass on the slides to this.